In this lecture video, we'll be solving quadratic equations by factoring, including examples from your Chapter 6, Section 6 lecture notes. A quadratic equation is an equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0. Notice that the left side of this equation looks very familiar. We have factored this type of quadratic expression. Having the equal sign makes this a quadratic equation. And when we write it in this way, that's considered the standard form of a quadratic equation. Let's talk about the zero factor property. Suppose we have two real numbers, a and b, and they have a product of 0. Then it must be true that a is equal to 0 or b is equal to 0. Otherwise, their product cannot be 0. In other words, with real numbers, the only way to have a product of 0 is if one of the factors being multiplied is 0. Let's use this property with this first example. We have x plus 6 times 2x minus 3 equals 0. That is, we have two factors that when multiplied together give us a product of 0. This means that x plus 6 equals 0 or 2x minus 3 equals 0. If x plus 6 is equal to 0, that means that x is equal to negative 6. And if 2x minus 3 equals 0, that means that 2x must equal positive 3, or x equals 3 over 2. This gives us a solution set with two real numbers. X can be equal to negative 6 or positive 3 halves. And there are two solutions to this equation. Let's go on to example 2. In example 2, we will again use the zero factor property to solve the equation. We have two factors, x and 4x plus 9, with a product of 0. That means that either x equals 0 or 4x plus 9 equals 0. Our first equation is already solved for x. The second one, 4x plus 9 equals 0, we can solve as 4x equals negative 9, and dividing both sides by 4, we have that x is equal to negative 9 over 4. We again have a solution set with two real numbers. X can be equal to negative 9 over 4, or x can be equal to 0. We again have two solutions to this equation. Looking at example 3, notice that this time we are given a quadratic equation in standard form. We're going to use our zero factor property to solve this equation. From previous lessons, we know how to factor x squared minus 12x plus 20 into two binomials. Since we have a simple x squared, the first term of each binomial is simply x. Now we need to look for two values that multiply to positive 20 and add to negative 12. Those will be negative 10 and negative 2. Now that we've factored the quadratic that's on the left side of this equation, we can use the zero factor property. With two factors having a product of 0, it must be true that x minus 10 is equal to 0 or that x minus 2 is equal to 0. If x minus 10 is equal to 0, that means that x must equal positive 10. And if x minus 2 is equal to 0, that means that x must be positive 2. We again have a solution set with two solutions for x. X can be 2 or 10. Let's go on to example 4. In example 4, we again have a quadratic equation in standard form. Since we have a 4x squared, let's see if we can't factor out a greatest common factor other than 1. All three terms are divisible by 4, so we'll start by factoring out a 4. 4 times x squared is 4x squared, 4 times 15x is 60x, and 4 times 56 is 224. Now we have a quadratic expression that's a little simpler to factor. This will factor into two binomials with a variable term of x. We need to find two values that multiply to positive 56 and add to positive 15. Let's start looking through our factors of 56. There's 1 times 56, 2 times 28, 4 times 14, 7 times 8. And 7 times 8 is our winner. The product of 7 and 8 is 56, and the sum of 7 and 8 is positive 15. So now we know our two binomials are x plus 7 and x plus 8. Now we can use our zero factor property. We have 4 times x plus 7 times x plus 8. Clearly the factor of 4 can't be 0, and we can even simplify that away by dividing both sides by 4. In other words, x plus 7 can equal 0, or x plus 8 can equal 0. If x plus 7 is equal to 0, that means that x must be equal to negative 7. And if x plus 8 is equal to 0, that means that x must equal negative 8. So we have a solution set with two values. X can be equal to negative 8 or negative 7. Here in example 5, we again have a quadratic equation in standard form, but this time we don't have a greatest common factor other than 1. So we'll try to factor this quadratic expression as is. Let's factor by grouping. In order to factor by grouping, we're looking for two integers that have a product of a times c, which in this case is 3 times negative 5 or negative 15. They also need to have a sum of b, which in our case is negative 14. We could use negative 15 and positive 1. Negative 15 times 1 is negative 15. Negative 15 plus 1 is negative 14. So we'll split our bx term as the sum of negative 15x plus 1x. Looking at our first two terms, 3x squared minus 15x, we can factor out a 3x. This leaves us with x minus 5. Looking at our last two terms, the greatest common factor is 1. So we'll simply write this as 1 times x minus 5. Factoring out an x minus 5 from the first group leaves us with a 3x. And factoring out x minus 5 from the second group leaves us with a plus 1. Now that the left side is factored, we can use our zero factor property. With two factors having a product of 0, we must have that x minus 5 is equal to 0 or that 3x plus 1 is equal to 0. If x minus 5 equals 0, that means that x must equal positive 5. And if 3x plus 1 is equal to 0, that means that 3x must equal negative 1 or that x must equal negative 1/3. This gives us a solution set containing the two values negative 1/3 and positive 5. Let's go on to example 6. Example 6 looks slightly different, but it's still a quadratic equation. Subtracting the 81 from both sides, we have now written it in standard form. Notice that in this case, our a is 1, b is 0, and c is negative 81. Notice that the left side is the difference of squares. So we can use the rule that the difference of two squares, a squared minus b squared, factors as a plus b times a minus b. Since x squared minus 81 is equal to x squared minus 9 squared, we can factor it as x plus 9 times x minus 9. Now using our zero factor property, we know that x plus 9 must equal 0 or that x minus 9 must equal 0. If x plus 9 is equal to 0, that means that x must be equal to negative 9. And if x minus 9 is equal to 0, that means that x must be equal to positive 9. So there's our two solutions for x. We have a solution set containing the two values negative 9 and positive 9. Let's look at another example where the quadratic is not given to us in standard form. In example 7, we have two terms on the right side of the equation that we need to move over to the left side to have this in standard form. We can first subtract 6x from both sides, which gives us x squared plus 5x equals 24. And subtracting 24 from both sides, we have x squared plus 5x minus 24 equals 0. Now we have a quadratic equation in standard form. Let's factor the left side. Since our leading term is a simple 1x squared, we know that our variable terms for the two binomials will be simply x. Now we need to find two values with a product of negative 24 and a sum of positive 5. Since the values we're looking for have a negative product, we need one of them to be positive and the other to be negative. Looking at our factors of 24, can you see which pair could have a sum of positive 5 if one factor is positive and the other is negative? 3 and 8. If we make the 3 negative and the 8 positive, they'll have a product of negative 24 and a sum of positive 5. Now we have x minus 3 times x plus 8 equals 0, and we can use our zero factor property. This means that x minus 3 equals 0 or x plus 8 equals 0. If x minus 3 equals 0, it must be true that x is equal to 3. And if x plus 8 is equal to 0, it must be true that x is equal to negative 8. So our solution set is the set of two values, negative 8 and positive 3. We have just two more examples. In example 8, the most tempting thing to do is to use the zero factor property right away. But we don't have a 0 on the right side. So even though the left side is already factored for us, we cannot use that property with the quadratic in this form. We must first write it in standard form. Subtracting 60 from both sides, we have x times x minus 4 minus 60 equals 0. Now the left side is no longer factored for us, so we need to multiply the first term and then refactor the entire left side. We'll have x times x and x times negative 4. X times x is x squared, and x times negative 4 is negative 4x. Now we can factor this quadratic expression. With a simple x squared as our leading term, this will factor as two binomials with x as their variable terms. We now need two values that multiply to negative 60 and add to negative 4. Two numbers that work here are negative 10 and positive 6. Negative 10 times 6 is negative 60. Negative 10 plus 6 is negative 4. Now we can use the zero factor property. We now know that x minus 10 can equal 0 or x plus 6 can equal 0. This means that x can equal 10 or that x can equal negative 6. So our solution set is the set containing the two values negative 6 and positive 10. Let's take a look at our last example. Example 9 asks the question the other way around. This time we're going to find a quadratic equation in standard form with integer coefficients that have this as the solution set, negative 5 and 12. So we want x equal to negative 5 to be one of our solutions and x equal to 12 to be the other solution. In order for negative 5 to be a solution to this quadratic, we need x minus negative 5 to be one of its factors, or x plus 5. In order for 12 to be one of the solutions, we need x minus 12 to be one of the factors. Now we have a quadratic equation with negative 5 and positive 12 as solutions. Let's distribute and write this in standard form. We'll first have x times x, or x squared, x times negative 12, or negative 12x, positive 5 times x, for a positive 5x, and positive 5 times negative 12, or negative 60. Combining like terms on the left, we have x squared minus 12x plus 5x, or minus 7x, minus 60 equals 0. If this beginning part was difficult to wrap your head around, consider looking at it a different way. We want one of our solutions to be x equals negative 5. Adding 5 to both sides of this equation gives us x plus 5 equals 0. So we want x plus 5 to be one of our factors. It's like using the zero factor property in reverse. If we want a solution for x to be positive 12, we could subtract 12 from both sides of this equation and we would write x minus 12 is equal to 0. So x minus 12 is one of the factors that we need. Again, using that zero factor property in reverse. And that will conclude this lecture video, solving quadratic equations by factoring.